Hey there, guys. We're going to look at some reflections here. Reflections are one of 4 transformations which you need to know for GCSE or IGCSE. So there are reflections, rotations, translations, and enlargements. And this Transum website is really has some really good practice on here. You don't need to sign into it. You can just do these examples straight on each of the tabs. So let's get straight into this. Let me just show you how it works. So for example, in this one on the left-hand side, it says draw the reflection. Well, let's play around. You can see it kind of goes like this. Teaching this at the moment. I'm just showing you how the site works. And there we go. I can check my answer. Oh, my answer appears to be wrong there. Oh, because answer's wrong. Because it says do it in the y-axis. Oops. Okay. So show the answer as well, and it will show you where the answer is. Okay. So that's how the website works. Let me just take a couple here. And I'm going to talk about reflections in the x and the y-axis, then reflections in particular lines x equals and y equals, and then also some diagonal lines as well. So let me take, for example, let me take this one here, okay? So let me copy this one now. And we'll take this one here. It's asking us to draw the reflection of the shape in the x-axis. Now, obviously, you can do this on the website, but I'm just going to talk around how to do it. So, okay, so when you see any particular point on the shape which they're asking you to reflect, you need to count from that point to the line of reflection and then across to the other side of the line of reflection. So this one wants us to draw the shape, the reflection, so the image, okay, whereas we start with the object and we're going to come up with the image, okay, after the reflection. And this is going to be reflected in the x-axis. Obviously, this one is the x-axis here. It's even labeled as x. So if I wanted to take, for example, this point here and reflect it across the other side, all I'm going to do is count my squares. So I'm going to count 1, 2, 3, 4, 5 to the line. And I'm going to count 5 on the other side as well. So 5 squares on the other side. And then I should get this point turning up here. So basically, every point is the same distance across the mirror line or the line of reflection. Okay, and if we take the next point down, so let's take this one here. Okay, now I can see that quite quickly that that's 4 boxes down to the x-axis. If I take 4 boxes to the other side as well, counting 1, 2, 3, 4, 1, 2, 3, 4, then I'm going to get my new point. Now, if I keep doing that, with each of those points, I should develop the new shape. Now, most people can see these quite quickly. So once you've got a couple of points, you know, if I then think, okay, I'm going to do this one next, I can see that's a 3 across there, 3 across there, or I can count 5 to the line and then 5 on the other side again. So that's going to take me to here. Once I've got a few points in, I can then just draw the rest of the shape. So I can see, for example, that this length here is 3 down, so that's going to be 3 up instead. I've got 3 across, it's going to be 3 across, and I can see it. That's perhaps the tricky bit is these diagonals. So I can see that it goes 1 in from here, and that associates with this point. I'm going to go 1 in, and then I might leave the diagonal to the last. So the diagonal is this one here. So leave the diagonal line to last. Okay, now if you've got an object which is actually touching the line, so say for example we have, I don't know, for example we have, let's do it. Let's do something like a triangle here. Okay, so here, and let's go down to this point here, and let's go up like that. Okay, now if you've got any point which is actually touching your line of reflection, then that's a little bit like if you went up to the mirror and your nose was touching the mirror. Your reflection would also be touching the mirror with its nose, with your reflection's nose as well. So the two things would come together at that particular point. So if anything is touching the line, there's no counting to do. The point is going to be in exactly the same place. That one is going to be in the same place. Then, of course, we can do the same with the other one. So if I take this blue cross, I can count 1, 2, 3 to the line, and then, of course, 3 to the other side takes me here. And then most people will find it quite easy to complete it anyway, but let me just complete that one. So that's 3 to the line and 3 to the line, and then I can just join things up again. Okay, so there's that. Then you also need to be able to reflect in lines like y is equal to 1, or x is equal to 1, or x is equal to minus 1, or x is equal to 2, or whatever. Okay, so you need to know about those lines as well. Now, this line here, I'm just going to try and put this in so I'm a bit scruffy here. You'll lose marks for being scruffy in an exam, but I'm sorry, I've just got a pen in this case. Right, so this line here is the height of 1. And that means that we've got a height of 1. The height is defined by y. Y is the height. So we've got y is equal to 1 there. And I haven't put my numbers on this axis, but I'm assuming it's like a 1, 2, 3, 4. It's going up in ones. Okay, so that would be my height. Excuse me, that would be my height of 1. Okay, now if I wanted a distance across of 2, yeah, so that line there will give us a distance across of 2, and distance across is x. Now, this is a bit strange really, because the x-axis is horizontal, but when we say x is equal to 2, that's vertical because it defines the line or all of the points on a line which are 2 across from the y-axis. So in fact, the y-axis itself has an equation of x is equal to 0, because on any of those points, let's take this point here, that's going to be point 0 minus 2. Okay, but on any of those points on that line that you take, the x value is going to be 0. So we say x is equal to 0. We're 0 across. Okay, so now we've got these two lines on here. If we wanted to do, say, for example, this shape reflected in y is equal to 1, then again, we just take all of our corner points, count to the line, and then count across to the other side of the line. So, for example, this cross would end up here. Okay, this cross here is now 4 to the line, 4 to the other side of the line is here. And so you can keep doing that again. Also, you might like to be able to define other lines, including negatives. So you should be able to think, what is the straight line here? So this straight line is y is equal to minus 3. This is a height of minus 3. Okay, so you should be able to do it with negatives as well. Now, if you were going to reflect this across that line, it would go down here somewhere. We wouldn't actually be able to fit that one in. Okay, finally with reflection, it is commonly asked for you to reflect across diagonal lines. So let's take this diagonal line here. You might know what the equation of this line is as well. So this diagonal line has coordinate points on it, 5, 0, 0, the origin, 1, 1, and so on. Okay, and you can see that minus 2 is down here. Okay, that's down there. Okay, so all of these points, you can see for all of those coordinate points, the first number is equal to the second number. Well, when we have coordinate points, we always put the x number first and the y number afterwards. Because the x and the y are the same for both parts of those coordinate points, we can say x is equal to y or y is equal to x. So this is the line of y is equal to x. Now, I'm not going to go into this a lot, but if you want to do the other diagonal, so this one here, and that's going to be the line of y is equal to minus x. Okay, it has a gradient of minus 1, whereas this one has a gradient of 1. This one has a gradient of minus 1. It's a hidden one. Okay, so you need to be aware of those things. I'm just going to do the straightforward y is equal to x reflection here, and this is slightly different. So for this one, you need to count across, turn the corner, and then go down. Okay, you do that with all of them. I count across, 6 across, and I go down 6. change color, do it with another one. Let's do this point here, go across 5 and then down 5. It's going to take us to that point there. Sorry, it's a bit scruffy. And then let's take, we can do it the other way around as well, by the way. Let's take this point here. So this one is going to go down 6 there and then across 6. So it's going to take us to there. And likewise, you can, as long as you go to the line and then you go and then you switch direction. So this one, for example, at the top, is going to be 9 down and then 9 across. And at some stage, you should be able to draw your shape in. So you can see that we're going to join all of these crosses up in the same order in which they're in the original shape. And I'm missing something here. I'm missing my in part, and I might have to do this last point as well. You can actually see it should be here. Okay, so draw that down and draw it up. So that's going to be our shape drawn there, reflected about a diagonal line. Okay, now that's not the only way to do this. There is another way to do this. The other way would be to say, okay, well, again, let's put that line in. Okay, so the other way to do this would be to count diagonal squares. So say, for example, this coordinate point here. If I counted diagonal squares, I get 1.5, and I go across again, I go 1/2 and 1. So now we're just going directly to the line, at right angles to the line, and then plotting the point on the other side there. Okay, so we counted 1.5 and then 1/2 and 1. Let's do that again. We've got 1, 2, 3, 1, 2, 3. So you can count diagonals instead of turning a corner. That's up to you. Okay, guys. Well, thanks for listening to this one. I'm going to do a video on level 2 next, and level 2 is about translations. So thanks for listening, and good luck with the exercise here.